Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Nice to see you again in this next part of our lecture. For today, we are going to study or we're going to cover this topic of problem formulation. So before going further, let's look at what you have discussed in the previous weeks. Not only you, but the previous classes. I'm going to share what has been discussed in the previous classes and in your class, and in terms of the definition of research. So one of the group in November 2020 says that research is a scientific and systematic investigation process to generate new knowledge and fill a research gap. And they also say that research is scientific and systematic investigation process to solve a research problem. So if you were to ponder upon this, they say that research is, the keywords always come up is scientific, systematic, investigation, generate new knowledge. Yeah, it's a process to generate new knowledge. And in this case, they add a research gap. So here also, the other part of the definition is, they said research is scientific and systematic investigation, which is similar to the top one. It's a process to solve a research problem. You see, between the top and the bottom, the difference is only here to generate new knowledge and fill a research gap, or to solve a research problem. Okay, we go to the other class. The other class in November 2020 also says that research is investigation process, which is systematic and scientific, starts with a research problem or gap in knowledge or flaws in previous research or unknown, and ends with solution. So we can understand here that the solution that they're talking about here is the solving of the research problem or filling in the research gap or the knowledge in gap in knowledge, or to fill in the flaws in previous research, or to find the unknown. And that's what they call the solutions, which is similar to the group before this. So you see the next one, another class in March 2021. Research is a process of investigation involving scientific method, almost similar. Okay. Discovering new knowledge. So we're talking about new knowledge, or you fill in a knowledge gap, which is new knowledge, right? And facts from reliable sources with a view to find solution to a problem. Okay. Next, research is a process of investigation involving scientific methods to discover new knowledge to find a solution to a problem. So very similar, find solution to a problem and discovering new knowledge. This is the other group, slot S. Research is a systematic process involving investigation, fulfilling the scientific inquiry, analysis, problem solving to solve, to contribute to the body of knowledge. So the terms that keep up recurring is systematic process, investigation, scientific inquiry, problem solving, new knowledge. And I think this is the last one. In your case, research is a scientific process of doing investigations, systematic approach, acquire new knowledge, and develop solution for particular problems. So you see here the keywords that keep on appearing and so on. Then you see that research is basically to generate new knowledge. So research is a systematic investigation process to obtain new and valid knowledge. It is systematic and orderly. It is based on scientific method. The purpose is to come up with new knowledge which must be reliable and valid. And this is a general definition which applies to all disciplines. So if you were to consider this, which is what you have done or your previous predecessors or the other groups have done, they have you know, this is like a summary of what you have decided in your respective groups that will covers this part, that research is systematic and orderly based on scientific method to come up with new knowledge, and the knowledge must be reliable and valid. So this is a general definition which applies to all disciplines, not only for scientific or engineering and technology definition, but I mean engineering or technology research, but also in all field of disciplines. Let's see an example. Sorry, when we say that, sorry, say, when we say that it is scientific and systematic, then we see that this is maybe some of you can immediately relate. This is the slide taken from John's work. Yeah? John's work on his grandma spread, where the systematic and scientific method that he used starts with problem question, and then he did some observation research, and then he formulated a hypothesis, he did experiment, he collected and analyzed results, and made some conclusions and communicated the results. If you see, as I said before this, that this is applicable to all kind of research, or except for the formulation of hypothesis there, okay? But all kind of research will have this systematic way of looking at of doing the investigation, and in fact, this is can be put in a different manner for our kind of research. So our research process should be firstly problem formulation, formulate the problem, and then you develop the methodology, you do the data collection, data processing, data analysis, interpretation to obtain findings, disseminations, and conclusions. So this is basically similar to John's systematic process, and this process is applicable to your research at master's and PhD levels as well. So if you see in this process, the first part is always problem formulation. Just like John's work started with problem formulation. He formulated the problem, then he solved the problem. So he tried to solve the problem. So when we talk about problem formulation, we are looking at research problem formulation. Okay, so we must start with research problem formulation. We are not talking solely about actual problem faced by humankind or human being or you and me. The problem may be about not having enough money to spend, or not having food to eat, or not having housing, or global warming, or flooding. All these are, yeah, human problems, but research does not necessarily, okay, research investigations that we are doing at master's and PhD levels do not necessarily are meant to solve those problems specifically or directly. So when we talk about problem here, it doesn't mean those human problem. It means more like the research problem. We are talking about research problem. Research problem is, as we see later, that if research starts with a research problem, Research is to and we know that research is to generate new knowledge. Okay, to generate new knowledge, researcher needs to know what that the knowledge he or she is generating is new. Very important. We must make sure that we know that this knowledge that we are going to generate in our research is new. So, when we say research is to also solve a research problem, it means that research problem that we are talking about specifically is actually the gap in knowledge. It is the unknown or the missing knowledge. So what we do not know, that is the problem. So it's not so much that there's flooding, there is not enough electricity, you know, uh, the issue of global warming, the issue of corrosion problem in ships or in vehicles or in machinery. Those are real problems, yes. But our own research do not necessarily directly are meant to solve those problems. Those are so even if you do not solve those problems, still you are doing research if you are you have research problem. You solve research problem. Okay, what we mean is that research problem is actually the other name for research problem is gap in knowledge. What people do not know about this matter or this issue at this point in time. Okay, so if there is something that you are looking in your research that people do not know at this point in time, it means that you are doing research. You are looking for that knowledge or that new information. Yeah, then you are doing research, even if you are not actually solving humankind problem directly. I'll explain what we mean. Yeah. Okay. We go to the next slide, is this one. As we said just now, as I have shown the the activities, yeah, for research activities, yeah, systematically you must start with problem formulation. You must start with the problem. If you do not know your research problem, you have a big problem. And that's the real problem. The big problem at the end is a real problem that you're facing because you face the problem you do not know how to do research. But the first part of the problem is this one. Research problem is actually gap in knowledge. So if you do not know this one, okay, which is your gap in knowledge, then you have a big problem. So this big problem is actual trouble that you are facing, yeah. So let's see the example here. Okay, we see that we need to formulate our problem. Yeah. So this set of this class will explain to you two parts. The first one is how to identify the knowledge, okay, the unknown, and how to write it down. Okay, we write down the problem by not by doing this by writing these 4 or 5 parts. Okay, we are going to write the problem statement. Okay, and then we're going to write the purpose statement. We're going to write the objectives, the scope, and significance. These are the 5. And then sometimes we need to write the hypothesis, but this is not compulsory or not necessarily available for all class, all research. Right. So the first part, which we are going to cover in this next class mainly, or in this the rest of the class today, is part 1, which is identification of problem or knowledge gap or the unknown. Because if you can identify that, then you can start research. If you do not identify the problem or the knowledge gap or the unknown, then you cannot start research. Okay, So you see, this example, research problem can be identified by asking a series of questions until the questions could not be answered with the present knowledge. You can, for example, look at these people who are studying the mummies. Yeah, they do archaeological digging in Egypt, for example, or even in South America, and they study the mummies. So studying the mummies do not have any practical problem being solved. It's not meant to solve any practical problem faced by humankind at the moment. But still they're doing research. They can get a lot of PhDs and masters by studying the mummies. So again, please remember when we talk about research problem, we are only talking about the knowledge unknown, knowledge gap or the unknown. Right. Let's see. Like for example, people who are looking at this mummy, they will study. Maybe they ask a question: when was this mummy buried? How old was she when she died? Why does the mummy has a broken leg? Okay. So you see, these three questions are very specific to this mummy here, and they were asking these questions. And obviously, if this mummy is new, yeah, they just found it, then all these are unknown. These are knowledge that people do not know. Nobody can claim that I know when this mummy was buried. I know how old was she when she died. I know why she has a broken leg. Okay, because there's nothing published about the mummy because the mummy has just been found. So somebody who found this mummy and made a study about this and answered this question, he can claim that he has a research problem. This problem is these are the problems that he was looking at, and if he find the answers to this problem, he can claim to have new knowledge, which he can publish in papers, in conferences, in theses, and so on. Yeah? And he can claim masters or PhD because of the study that he did to fulfill or to fill in this gap in knowledge, this unknown. Or maybe they also study maybe what was the typical diet of the Egyptians during that period. Maybe they study the gut or the stomach of this mummy and see from there, from whatever content, then they can understand what was the typical diet of the Egyptian during that period. Was there forest in the area of the burial site 5,000 years ago? Or was it already a desert? So you see that in question number 1, 2, and 3 here, I mean the first three questions, definitely nobody has answered this because this mummy has just been discovered and the questions are directly related to the mummy. All right. But question number 4, which is this one, typical diet, this could have been answered by somebody else who had studied a similar mummy in that period, during that period. So uh, if you were to ask this question, somebody say no, somebody has published. If they found that this mummy was buried maybe 5,000 years ago, maybe 4,000, 3,000 or 4,000 years BC, and people have studied many studies done on Egyptians in that period. Actually, the answer is already there. So this is no longer a new knowledge. Okay, although you want to study this the diet of this mummy, it's no longer valid as a new knowledge because people know already a lot of things have been published about the diet of the Egyptians during that period. Unless you claim that after you study that this mummy was buried maybe 7,000 years ago, and then really there's nobody has published anything in about 7,000 years ago Egyptians diet, then the researchers are contributing new knowledge. Okay, so you see number 1 to 4 here. They, if the researchers answer the question, they solve the do they solve the problem or not? Yes, because the problem is about the knowledge. But do they solve any human trouble or okay, real human problem? No. We in terms of actual use of the knowledge directly, we even if we know when this mummy was buried, it doesn't solve any problem about us at the moment. Our present our present life, our present era that we're living on has nothing to do with what how old was she when she died and so on. But still, the study is very significant and can be published in very good journals, and people are interested about this. Okay. But there is another question here, the last one. Was there forest in the area of the burial site 5,000 years ago, or was it really already a desert? So this question is interesting because number one, could be somebody has answered this question. Okay. Number two, maybe nobody has answered this question. Okay. And number three, the answer to this question has a physical significance on our present era. Okay, it has some relationship, not directly with our present human being problem, because we are having problem with desertification. You know, our forests in Africa, North Africa particularly, are turning into desert. Okay, so maybe by understanding what happened to the Egyptian desert at that time, maybe if there was really a forest. Okay, and because by studying the mummy, maybe from the wood of this coffin or sarcophagus, we can find out that the wood was actually local, you know, all those sort of things. Maybe from there, we can deduce that actually Egypt 5,000 years ago was actually a forest, not a desert. Then maybe from there we can try to deduce something that can help us solve our present desertification, yeah, of the North Africa area. You know, the Sahara is getting bigger and bigger because the forests are dwindling and disappearing, giving way to deserts. So what we want to point out here is that research problem is about knowledge. It's not about human being troubles. Okay, so that's something that we need to remember. Okay, now let's see how do we uh, find out this research problem. As you said, we can ask a series of questions. Now let's see the example of John. Remember our friend John who did his work on the size of grandma's bread. So he must have started his work with a problem statement and with a problem, a research problem. He must have started with a research problem. And what was the title of his work? He has something about to do with the effect of amount of sugar on the size of bread. And this seems to be his hypothesis of his problem, uh, uh, and that he's trying to solve. But what we want to see is how did John finally decided that this is going to be his problem or the issue that he wants to study. Okay, the problem statement, the research gap. Let's see. This is a hypothetical work, as you may understand, but it gives an example of how we can think of developing your own problem statement. So, of course, he started with something which is a practical problem that he's trying to solve. The practical problem is we need bigger size bread loaf size. We need a bigger size of bread from grandma's bread making process. Why? Because bigger bread is better. But the question is how to get bigger bread. Okay, so if we say that we want to get how to get bigger bread size, then we need to first see in the literature what has been studied on ways of getting bigger bread size. What has been studied? And of all those studies that has been published by other people, what was the best option? Okay, so of course this is, as I said, it's hypothetical, it's fictional, but I make it up, I made it up as if that yes, somebody have already studied how to get the grandma's bread to be bigger. Okay, so you just stay with me, and you see that it's as if maybe somebody like David 2010 studied the effect of temperature on grandma's bread. Okay, and Musa studied about flour, and Josh studied yeast. Hadi studied also studied about yeast. You know, they change maybe the kind of yeast or the amount of yeast and so on. And Wong and Lim and Ali studied sugar. So you see that many people studied about different things to get the same problem. I mean, to solve the same issue here. Issue is how to get the bread size bigger. But so the knowledge that they have generated is that David generates some knowledge about temperature, about flour, about yeast, about sugar. And out of all these studies, David found temperature has an effect, maybe not so much. Flour has an effect, but not so much. Yeast has an effect, but not so much. But Wong and Lim, they proved that sugar has a big effect. So if we were to ask what was the best option, so John will want to look at all this and say, oh, Lim and Wong, all these two studies shows that sugar has an effect. So I'm going to concentrate on sugar. What did Wong and Lim study? So what has been studied about sugar? Okay, and what was the conclusion? So he take these two and found that Wong studied the different use of white sugar and brown sugar. Okay, while Lim and Ali studied fine and coarse sugar. So Wong found that white sugar is the best. If you want to use sugar, you use white, not brown. And Lim and Ali proved that fine sugar is better than coarse sugar. So John concluded that white sugar and fine sugar will be the best option to get bread loaf, big bread loaf. To get big one, okay, these are the two, this is the best option. You use white sugar and fine sugar because that's from the literature, okay. But now, what can be studied now? If I'm to study just to find out whether there is white sugar is better than brown sugar, somebody has done it. If I want to study between fine sugar and coarse sugar, somebody has done it. So John asked another question: what has been studied about the amount of effect of sugar on the size of bread? And he found it's none. Nobody has studied the that no one has tested the effect of different amount of fine white sugar on the size of bread. So that become the gap. You see? So that's the gap in knowledge that John is going to look at. He's going to focus on the effect of the amount of fine white sugar, yeah, on the size of bread. So this, you see how from the big question there, yeah, I mean how to get bigger bread, he focused and finally he found that this is where he's going to get. So this pyramid, inverted pyramid or inverted triangle here is actually to help us to zoom in on the actual part that people have not done. So this gap is important because if he stick to here, The top part here, temperature people have done, the effect of temperature, the effect of flour, the effect of yeast, the effect of sugar. Just effect of sugar, just sugar maybe. eh, the effect of sugar has been studied only the two aspects of effect, which is white sugar and brown sugar, and fine and coarse sugar, without looking at the amount. So he found out nobody has done the amount or different amount of fine white sugar. So that's what he chose to be his problem statement. So the research problem, he can say that a lot of research has been done in this field. However, no research has been carried out, okay, to study the effect of different amount of fine white sugar to improve the size of grandma's bread. So this is his problem statement. So this is his problem statement. So although this is hypothetical, as I said, this is only fictional, okay, but it gives you uh, an indication or guideline on how we want to formulate our own problem. In your case, your problem, you can formulate by asking questions like this. What has people done? What have people not done? That's important. So you need to find out what people have not done. Okay, so that's the gap knowledge. If you ask questions and people have done everything that you want to do, then basically you need to find something else. So you need to find something else. Right, we move on. So this is an example problem statement for John, of course, as we written just now. For John, as we have explained just now. And we see some other examples. So for example, there's a corrosion mitigation of wind turbine blade using nanomaterials. Again, this is hypothetical case. Just to make it a bit more practical, yeah, a bit more, I mean, the more relevant. Just now, John's uh, is only talking about grandma's bread. Now we see about something engineering and technology. So he finally, this guy who's going to study about corrosion mitigation of wind turbine blade using nanomaterials, he finally will zoom into this part. Despite availability of a lot of literature on corrosion mitigation of wind turbine blades, no research has been done to study how nanomaterials coating work and if it is suitable for controlling corrosion of wind turbine blades. So you see that you need to have something like this as a problem statement. You must show that you know the literature, you know what people are doing in this area that you're doing, that you're studying, you must prove confidently that no one has done the work that you are going to do, or no one has found the knowledge that you are going to search in your current work. Okay, so that's important. Right. We go on to some more examples. Okay, so here I share a method of a thinking process of how to develop the problem statement or the research problem. Okay, how to identify it. Just like John just now, he identified the research problem as being no one has studied about the effect of fine white sugar on the size of grandma's bread. How did he get that? Because he studied the literature. He asked questions. What has people done? Not necessarily about grandma's bread. Maybe somebody else was studying about other people's bread. There's no problem. But what did they do? What have they studied? What have not they not studied? So he is using their work, yeah, to actually define his own problem, research problem. And that's what you have to do as well. You have to find out who studied what at various levels. In this case, you see this example. Maybe we can ask question like, what are being studied to reduce greenhouse gas emissions? Maybe you can answer a lot of questions, give some answers here. And what are the options for renewable energy? What are the options? Yeah, I mean, what are the kinds of renewable energy? Because one of the answer for reducing greenhouse gas emission is renewable energy. Okay, what are the options? Well, the options could be wind energy, solar energy, hydro and hydro energy, yeah, biomass or geothermal and so on. Okay, so now you choose which one you want to go in. You want to go into hydro, or you want to go to solar, or you want to go into wind? Okay, I choose wind. So what are being studied in the field of wind energy? Okay, so maybe some people are studying about structure of it, maybe about location of where to put the wind energy, about how to estimate the power from wind energy, how to design the turbine itself, and so on. So, okay, I'm not going to look into the other parts. I'm going to look at the turbine structure. So focus now to turbine structure. Find out what people are doing about turbine structure. What are the areas being studied in turbine structure? Okay, people are studying about the 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 blades, how many blades that we put, whether it should be horizontal axis or vertical axis, whether the structure should be floating, maybe if it is offshore, or should be fixed, and all these are people are studying. And one of the issue that people are studying is corrosion. So, of the blades. All right, if you identify that as one issue that you want to look at, then what are the ways that people are doing to reduce blade corrosion? So you ask again the questions. And then once you do, you say, oh, one other way is to put coating to reduce corrosion. Okay, what are the types of coating being used now? Okay, and finally, are there new materials being used? And nobody has done, are there any work being done in nano coating for wind turbines? Okay, so these are the questions that you ask to finally zoom in that yes, this part that you're doing, okay, nanomaterials coating is something new, novel that people have not done before. So this is, for example, how uh, to identify the research problem. To reduce global warming, we need to reduce greenhouse gas emissions. So you ask those questions. Okay, and those are the answers that I mentioned just now, some of them, yeah. So global warming, reduce GHG. So the way to reduce GHG, there are a number of ways, but I'm going to choose renewable energy. So renewable energy, there are so many types. I'm going to choose wind. From the wind, I'm going to look at the turbine itself. Wind energy, we are going to look at the turbine design or turbine structure. And then from the turbine itself, what are the issues? Area, noise, blade corrosion, number of blades, type of turbines, etc. So I'm going to look at blade corrosion as the issue that I'm going to look at. And then I'm going to look at the coating and different type of coating, painting, interpreting new materials, and no work is being done on nanomaterials coating. So how does nanomaterials coating work? Can it be used for controlling corrosion of wind turbines? Okay, so because of that, you can write problem statement with something like this. Despite availability of a lot of literature on corrosion mitigation of wind turbine blades, no research has been done to study how nanomaterial coating work if it is suitable for controlling corrosion of wind turbine blades. And the research question, how does nanomaterial coating work? Can it be used for controlling corrosion of wind turbine blades? So you see, this is how we develop the research problem, yeah. Or finally, we identify the research problem and the research questions together. So we see some other example of your previous colleagues, yeah, your seniors. For example, this guy, he's looking at maritime casualties. That's the big issue that he's looking at, maritime casualties. But he zoomed in finally to say, to relate it to from reducing maritime casualties, he finally looked at meditation and whether meditation will be effective or not. So his study is going to be about meditation, the use of meditation to reduce individual fatigue of seafarers, yeah, these people on board ships, so that will reduce stress, and that reduce the fatigue and reduce the human factor in maritime casualties. Okay, so that's an example. You see another example? So of course, the research problem or research question is it, how effective is meditation in mitigating crew fatigue? Okay, so that your actual research problem is only this part. Is this part. This is the main thing that you are going to solve. All this has been solved by other people. Other people have done this, but this is where you're going to focus. Okay. So similarly, you go to the next one. Next one, Awang Azhar. He is doing work on blowout preventers. Blowout preventers are like valve that is put on top of the drilling. When people drill oil, they put the drilling uh, drill string, which is more okay. We can understand like pipes that goes down into the. This is talking about offshore, particularly. He was doing offshore, so we put the pipes to the seabed. We push it down until it hit the oil reservoir. The oil reservoir is actually under pressure. So you hit it, prick it, then oil will want to shoot out. Yeah, shoot out from the reservoir through the pipes, and that will cause problem if we do not have a valve. That valve is called blowout preventers. It's always on top of the drill string as we drill the well. Okay, the well. So um, the issue that he's trying to solve here is how to prevent the um, failure, okay, failure of this blowout preventers by having predictive maintenance. So you can predict if there is this blowout preventer is not working, you can predict it. So it starts from what are the ways to prevent blowouts. Okay, so of course you use blow uh, there are various ways, yeah, operational practice, structural instrumentation, safety critical element, drilling control system, and so on. So the safety critical element will consist of either surface or subsea. Surface is on the surface of above the surface of water. Subsea is below the surface water. And one the element in the subsea, so there are three elements: drain pipe, subsea manifold, and blowout preventer. So all people have studied, many people have studied about uh, these areas. You can safety critical element for the subsea and for surface. People have studied safety critical element, and then for the subsea, people look at how can be improved, how can drilling pipe be improved, how can subsea manifold be improved, how can blowout preventer be improved. And in this case, he's going to look at blowout preventer only. And for blowout preventer, he's going to make people look at the design of it, the reliability of it, installation of it. So maybe some people have studied about installation, but he's going to study about reliability. Okay, some people have studied about reliability, right? So in reliability, what has people studied? People studied about monitoring, maintenance, about risk management, mitigation. Okay, and then he choose to look further into monitoring maintenance. How are people doing it? So all these are from literature. All these people have done. All this uh, down to here, people have done it. But nobody has done something using IoT, Internet of Things, okay, for predictive maintenance framework. So because of that, he's going to focus on how to effectively implement IoT to produce a predictive maintenance framework. Okay, another example is Shafika here. She is looking at road traffic accidents. Okay, that's a big issue that she is looking at. But her research problem is not this. The research problem is about work-related safety health framework. Okay, so she's going to develop work-related safety and health framework which is actually contributing to this part, work-related road safety management. It's going to contribute to gig riders study, and gig riders is going to is actually on motorcycles, and the net effect is to reduce the work-related road accidents. Okay, so if you see that although these are important, this part are important, these are the practical human being problem, okay, but the work only at PhD level is only to look at this. Yeah? Similarly, like just now, one work is going to look just about meditation. The other one is going to look like just about blow up IoT. John is going to look at just the effect of changing sugar, amount of sugar. The other guys is looking at how nanomaterial interact and work to solve the wind turbine, improve the wind turbine corrosion capability. Yeah, okay, mitigate the corrosion problem. So you see that the study itself is very deep and fundamental at the fundamental level, and that is the knowledge that you are going to, or they are going to contribute, yeah, to the body of knowledge of what men now understand. Okay, so we have another example here, the effect of virgin called coconut oil on the performance of diesel engines. This is again another hypothetical problem, the effect of virgin coconut oil on the performance of diesel engines. So we want to improve the performance of diesel engine. What has people done to improve performance of diesel engines? Okay, let's see how the so for example that part so this research is written like this. Yeah, problem statement. Although just now it was only a summary, but here we give the citation or the literature. Much work has been carried out in improving the efficiency of diesel engines. This work have been summarized in Mark et al. 2016 and Kawashima 2015. Among the methods proposed are the use of additives in the fuel. The use of vegetable oil as additive has been presented by Tim and Wang, Slamat, and Musa and Reda, and Lim et al. You see all these citations, we are all literature, yeah? So what we show here is only the literature that's related to those part that was chosen as well. Vegetable oil. Okay, what people have studied about vegetable oil. So they give example here. They have used jatropha, palm oil, soya oil, corn oil, varying degrees of success. The maximum improvement was reported by Lim, who used corn oil in a medium speed engine, marine engine, and found a 10% increase efficiency. So this is basically the background, yeah? What people have done. And then previous work and improvement research has not studied the use of virgin coconut oil. So nobody has done it. So there's a gap, which has been shown to have superior qualities as reported by Hashim et al. So Hashim studied virgin coconut oil, but they studied it in a steam boiler. And they found that combustion characteristics were far superior with reduction in harmful and carbon dioxide emissions. So the conclusion says, review of the literature suggests that no research has been carried out to study the use of virgin coconut oil to improve efficiency of diesel engines. There's a need to study if this is possible, determine what is the right amount of VCO to be used. So the purpose of the research is to study the effect of VTO on the performance of diesel engine. The research will be undertaken by carrying out experiment on a 200 horsepower diesel engine in the University Combustion Laboratory. So we can see how we develop the problem statement, yeah, here based on literature. Well, what's the problem statement? We identify the research problem by asking which one had uh, uh, what has people done and what has people not done. Okay, so once you find out what people has not done, that is your problem statement. You proceed to solve that problem and using your methodology, collect data, and finally you present that. That is your research. So the process is simply said like that. Yeah? So you just identify your problem statement, carry out research to find the answer to those problems. Okay. So this is a class exercise that I expect all of you to do within 1 week. So before your next class next week, please do the class exercise. Just make a rough sketch of inverted pyramid for your own research. Snap a photo and share it during the next class. So we are going to have class next week. Please, before that class, you snap a photo or save as JPEG, no, don't not PDF, and just share in the group in our WhatsApp group. Yeah. With that exercise, we come to the end of problem formulation part 1 of the lecture. We are going to go next into problem formulation part 2, which will discuss about the writing of the problem statement, purpose statement, research questions, objective, scope, and significance, and also hypothesis if there is need for the hypothesis. But there will be, so this will be the content of the next part of our problem formulation and definition. But meanwhile, before going into part 2, we are going to divert a little bit into literature review, which is also I prepared another presentation on literature review itself. So you need to look problem formulation part 1 and then go into literature review, and then we come back to problem formulation part 2. Okay, so for now I'll end here, and after this you go into literature review, and then you come back to the problem formulation part 2. Okay, Assalamualaikum warahmatullahi wabarakatuh.